Welcome back. In this special series, I'm going to explain how you can find the derivative of a function from the first principle. Recall that, finding the derivative from first principles is just like an algebra way of finding an expression for the slope of a curve. Recall in my calculus in 5 minute series, I explained that when you say derivative or differentiation or differential coefficient is just like the slope of, finding the slope of a curve. So, and don't forget it is dy dx. So, during your high school, when you want to find the slope of a curve, you say dy dx is changing, let me say change in y divided by change in what? In x. So, that is dy dx the same thing as y2 minus y1, x2 minus x1. So if you want to know much more about this, please refer to my calculus in 5 minute video. So I've done that in Yoruba as well as in English. So like I've said, when we say, derivative from first principle, it's just like an algebraic way, or let me say, algebraic way of finding a general expression for the slope of what? Of a curve. So it is also called finding the derivative from definition. You understand that now? So in some text, they refer it as delta method. So you understand. And this derivative from first principles is just like a foundation so in differential calculus, so in essence, all the rule we are using, so being it the product rule, the quotient rule, even all our standard, derivatives. So they actually comes from this derivative from first principle, and it is defined as so that is when you want to find your derivative from first principle. So that is you have that your f prime of s equals to the limit as h tends to 0 f of x plus h minus f of x divided by h. So limit as h tends to 0 f of x plus h minus f of x divided by h. So we all know what limit of a function mean. So don't forget. And we know that our f prime of s here means, the derivative is just the same thing as y of what? Dy ds is the same thing as dy ds or y prime. So, you'll be wondering when I said it's an algebraic way of finding the derivative. Recall in my calculus in 5 minutes, I said when you have that your y is equal to s raised power n, then in general we say that our dy ds is nx n minus 1. You understand now? You know this is very trivial. Actually, this expression n dy ds is equal to n s n minus 1 was actually derived from this formula as well. So, but that's not where we are going. But the reason why I said like an algebraic way of finding the slope of a curve, you see that when I want to apply this to solve, the two function x square and 1 divided by root x. So you will see that it looks in forms of an algebraic what? Algebraic way. So if you want to find it, just put your limits as your h tends to 0. H here is the increment. So refer to my video, you will get more understanding on it. And you know your f of s plus h. Recall when you have that your f of s equal to s squared, for example. So then your f of s plus h will be what? So x plus h squared. You understand that? That is, whenever you see x before, you just substitute the value of s plus h squared. Yeah, you understand now. So if that is clear, let us do it. The first question we have that f of s is equal to x squared. That's the same thing since we are asked to differentiate it. It means this is our function. You understand? And don't forget by the definition, derivative from first principle is what? Limit as h tends to 0, f of s plus h minus f of s divided by h. You understand now? So now let us do the substitution. It means my f prime of s will be limit as h tends to 0. You know this my f of s squared. Then from here, you can say your f of s plus h will be what? With what I've explained up, wherever you see x here, you substitute s plus h. So when you have your f of s to be s squared, so it means when you are asked to find f of something, it means you just replace the x in that function to that something. With this f of 5, you are going to have f5 squared. With f of Gafari, you are going to have Gafari squared. So you understand that. So it implies that I'm going to have my f of s plus h here is going to be s plus h everything squared. So then I'm going to have s plus h everything squared minus f of s. What is our f of s? S squared. Don't be confused. At times they may just give you y as well. Your y is same thing as f of x, then divided by h. So, okay, if you now simplify this further, let me change my marker. Then I'm going to have f prime of x limit as h tends to 0. If you expand this guy, then I'm going to have x squared plus xh plus h squared. How do I get that? Recall that your s plus h square is same thing as s plus h multiplied by s plus h. So if you expand, you are going to get that minus s square divided by h. You understand? So then this guy, we cancel this guy. You understand now? Then I'm going to have what left? F prime of s equal to limit as h tends to 0. So xh plus h square divided by h. So you don't take the limit directly. You know, if you take the limit directly, so then you are going to have 0 indeterminate of the form 0 divided by 0. You understand now? So recall when you say your limit, I mean, as s tends to a, f of s, recall it the same thing as f of a. You understand now? So, but before you do that, just play with this guy. Since h is common in the numerator, then you can factor it out. So then I'm going to have limit as h tends to 0. You bring this guy out, then I'm going to have s plus h divided by h. So then this guy will cancel this guy. Then after that, you can now take your limit. So, and okay, let me rewrite it. F prime of s will now be limit as h tends to 0, s plus h. You understand now? Recall from what I wrote here, when you say your limit as s tends to a is equal to f of s, then the same thing as what? F of a by definition. It means wherever you see x now, wherever you see h here, you just put the value of 0. So then your f prime of s will now be s plus 0 is equal to s. So s plus 0, which is equal, no, I think I made, so this sh, something is missing. No, when you expand this is supposed to give me 2sh, sorry. So 2sh, 2xh, yeah. So then this will be 2x, 2x, and this is going to be 2s. Yeah. So then you can conclude that your f prime of s is equal to 2x. And that is very true because recall when you have your f of s to be s squared, you know, generally from what I've explained so far before, your derivative of s square will be what? You multiply the index by this, that will be 2s, then you subtract 1 from the index, 2, 1 minus 1. Then you are going to have 2s. Can you see now? So that's how you are going to obtain it from the first principle. So how do we do the second one? So it might look challenging because it's having radical as well as, I mean, the radical is at the denominator. But before I go, you know, you have your y to be 1 divided by root x. So which is same thing as f of x, right? Even before doing it, I can rewrite. Let's say I want to quickly check to know the value of, what I'm going to obtain. This one is same thing as s raised power minus half from your loss of indices. And when you differentiate it from what I've done up, so this will give you minus half s raised power minus half divided by minus 1. And that's minus half s raised power minus 3 divided by 2. So which we arrive at minus half. If you bring this guy here, this will be what? Square root of s everything raised by 3. So it means this is what I'm going to obtain. So that's what I'm going to obtain. So if that is the case, let us check it out and see if we are going to get that. Recall from the definition, your f prime of s is limit as h tends to 0, f of s plus h minus f of s divided by h. So divided by h. Okay, now if you proceed further, then I'm going to have that my f prime of s is equal to limit as h tends to 0. So your f of s is 1 divided by root x. So your f of s plus h will be what? I told you it means wherever you see x here, then you are going to replace it with what now? S plus h. And this one will give you square root of 1 over s plus h minus 1 divided by root x, because that's my f of x divided by h. Oh, so okay, now you can collect, you can find the LCM of the numerator, or before doing that, let me just rewrite this to make it neat here. Yeah, is that not so? Yes. So then I can have my f prime of s to be limit as h tends to 0. Then the LCM of this guy will be this. So how many? If you divide this by this, then this one will remit root x. Root x times 1, that's root x minus root x plus h. Is that? Then multiply by 1 divided by h. Okay, now let us proceed. This one will give me f prime of s equal to limit as h tends to 0, root x minus root s plus h. So if you multiply these two guys together, recall from your laws of sort, root a multiplied by root b will give you root 8b. So then that will give you what? Root s plus h into x. Then multiply by 1 divided by h. Okay, now, so when you simplify further, so then I'm going to have that f prime of s is limit as h tends to 0, square root of x minus square root of s plus h divided by square root of, you like, you can square this, s squared plus sh. Then I think we can have our h here. Okay, what are you now going to do to proceed? Are we going to substitute the value of h to 0 and take the limit directly? If you take the limit directly here, you will see that this will be 0, root s minus root s will give you 0. This will also give you 0. So you are still going to obtain indeterminate of the form what? 0 divided by 0. So then let's see if we can simplify it further again. What are you going to do? If I were you, you can just rationalize the numerator. You understand now? So you rationalize the numerator. How do you rationalize the numerator? It is not only the denominator you can rationalize. You can rationalize both the numerator and the denominator. And if you want to rationalize, it means you want to get rid of the radical. You understand now? So, and if you want to get rid of a radical, you multiply by their conjugate. So, for example, when you have root a plus root b, the conjugate of root a plus root b is what? Root a minus root b. Why is it a conjugate? Because when you multiply both together, you are going to have, a numeric, an expression without the radical, because this will give rise to what? The difference of two squares. So which is same thing as root a squared minus root b squared, which we actually cancel the radical for you. You understand now? So if that is cleared, okay, now let us apply the same thing here. If I rationalize the numerator, because even if you rationalize here, this h will be there. And if you take the limit, you are still going to have 0 at the denominator. So which will either give you undefined or indeterminate. So then this one will give you f prime of x, limit as h tends to 0, root x minus root x plus h divided by s into x square plus sh. So then multiply by root x plus h divided by root s plus, so root s plus h. What you do for numerator, you must actually do it for the denominator. So recall what I have here. It means without wasting my time, what are you going to have here? So that is what? Root x everything squared minus root x plus h everything squared from your what? Difference of two squares. Then you are going to have what's left at the denominator h, root s square plus sh, root x plus root x plus h. Okay, now if you continue from there, then I'm going to have that my f prime of s equals to limit as h tends to 0. This guy will cancel this. Then I'm having x. Then square we also cancel square root minus s plus h. Then divided by s. If I were you, you can leave this like this. They will soon cancel each other. sh root x plus root s plus h. Oh, so if that is the case, then I'm going to have limit as s tends to 0, s minus x minus h. You know how I have minus h minus times plus will give you minus. Then h square root of s square plus h into square root of s plus root s plus h. So s minus s will give you 0. Then I'm going to have limit as h tends to 0 minus h divided by square root of, okay, h is here, s squared plus xh root x plus h. So then you will see that h cancel h. Is that not so? Then I have what's left, limit as h tends to 0, this minus 1 divided by root s square plus sh multiplied by root x plus root s plus h. So I think we are safe to take our limits now. So if you now take your limit, recall when you say if your limit as s tends to a is f of s, then it is what? F of a. So then from there you can say that f prime of s is equal to wherever you see s now you put h minus 1 divided by square root of s squared. So this will be 0 multiplied by square root of x plus square root of x. You understand? So this will give me minus divided by square root of x squared multiplied by, so 2 root x. You understand how is 2 root x? So this guy we cancel. It's just like you're having 1 pen plus 1 pen. That will give you 2 pen minus divided by 2x root x. So if you like, you can, this is the same thing as s raised power 1. This is same thing as s raised power half. S raised power 1 multiplied by s raised power half will give you s raised power 3 divided by 2. You understand now? And s raised power 3 divided by 2 is same thing as square root of s everything raised power 3. You can say minus 1 divided by 2 square root of everything raised power 2, which we've predicted that we are going to have. You can check that again. That is your f of s is equal to what? 1 divided by square root of x, right? So then your f prime of s, you can write it as s raised power minus half. So that will give you minus half, s raised power minus half minus 1. That's minus half s raised power minus 3 divided by 2 minus 2 s everything raised by 3. So which is same thing as what we are going to obtain here. So that's how you are going to find the derivative of function from the first principle. So if you understand that, I challenge you to find the derivative of this function 1 divided by square root of x squared plus 1. So f of s is equal to 1 divided by square root of x squared plus 1, and put your answer on the comment box. So if you understand this video, please don't forget to like, share, and subscribe to my channel if you've not done so. Also, I've made several videos on different aspects of mathematics. You might also want to check them. Thank you very much. See you in another video. Bye.